Hey, PreCalc students. I'm starting off today by having my phone pointed at Desmos. Don't worry, you don't need this for this unit. I just wanted to show you something. We're learning our third shape today. It's called the hyperbola, and I just want to show you what it looks like before we start, okay? So, sorry, I'm moving my camera a lot. All right, so this is an ellipse. Obviously, we've been studying that. Okay, a hyperbola basically is like is related to the ellipse, but it's kind of the opposite. Let me show you what I mean. Okay, so that blue part, like this part, that's the hyperbola. And notice that they share this one common point right there. Okay, so like an ellipse is like the inside, and the hyperbola is what you get on the outside. So an hyperbola can do two things. It can go like that, or it can go up and down like this. Okay, and that's kind of what we're going to be learning today is like when does it go like this and when does it go like this. Okay, all right, so I have something I want to show you over here. Okay, so here's an equation. I want you guys to look at the one that's highlighted, the blue one right here. So see how there's an A in there? Okay, so what that A means is that that A is going to change values. Okay, and then I can push this little slider right here. See that? And it changes the value of A. So I'm going to show you what happens to the equation when the A value changes. Okay, so let me, hold on, I have to wait a second. Let me pause that, put it back to where I want it. Okay, all right. So this is a hyperbola, and if you notice right now, A is -1. Hopefully you can see that. A is a -1 right there. So I'm going to push this little slider, and it's going to change the value of A. Okay, so sometimes it's an ellipse. Then the ellipse gets fatter. And then boom, it changes to a hyperbola. The hyperbola changes shape, but notice it keeps that one common point. And then boom, it changes back. And then I'm gonna do it one more time because I just think it's fun to look at. Okay, it goes like that. Pause. Okay, so I don't know if you guys were able to look at both at the same time, but hopefully you've noticed that it's a hyperbola anytime A is negative, and it's an ellipse anytime A is positive. So positive ellipse, negative hyperbola. Okay, so we are studying shapes today where this, instead of being a plus, will be a minus, and that will make hyperbola. Okay, all right, so I'm going to move my camera. I want you guys to get out graph paper if you don't have any. There you go. Okay, hold on, give me 1 second. All right, sorry, I'm here. I had to turn on a couple more lights on. I forget, it's like dark out right now. All right, you guys. So the first lesson, always takes a little bit longer because we have to like establish the rules for the equations. I just want to tell you guys though that this week there's going to be 3 lessons, and then I'm going to do my first optional Zoom meeting, and I'll email you guys more information about it though. Sorry it's taking me this long. I'm just trying to get everything figured out. So we're gonna do like an optional Zoom where you just come and we chat, and we're not gonna do any math. So if you can't come or you don't want to come, you're not gonna miss out on any instruction. Okay. And then if people like it, then we will continue with these after spring break. Okay. So you guys have 1 more week to go. You guys are doing awesome. I can't believe not only that you guys are turning in your homework, but the quality of homework I'm getting is really great. So thank you guys. Okay. So let's do this. First thing I want to write down is just the equation of the hyperbola. Okay, so sorry, I keep forgetting that blue isn't working very well. Okay, so equation of a hyperbola. Okay, all right. So the first thing I want you guys to write down, there's 2 equations, just like there's 2 equations for the ellipse. It looks identical to the ellipse. X minus h squared over a squared minus y minus k squared over b squared equals 1. So the only difference between this hyperbola and the ellipses we've been studying is that this one has a minus sign, which basically like takes the ellipse and flips it upside down like this, or inside out would be a better word, okay? All right, so this one we're gonna kind of carefully draw out. So take, I'm not doing this one on graph paper, I'm just gonna draw it over here. So I'm gonna draw my axis. All right, and this one we're just gonna have the center be 0, 0, just for my ease of picture. Okay, so basically, for this one, the center is 0, 0. If I were to graph an ellipse, I would go A in the x direction. So I'd go out this far, and I'd plot a point. Okay, if it was an ellipse, I'd go B in the y direction, and I would plot a point. And depending on, you know, which one, and then depending on which one was bigger, you know, the ellipse would either go this way or this way, okay? You're gonna do the same exact thing for the hyperbola, except you just don't draw the ellipse, okay? So you still go out A in the x direction, B in the y direction, okay? But instead of drawing an ellipse, I want you guys to draw like a little box. Like this. And this is A, and this is B. All right, so one thing that's really hard for kids to wrap their brains around is that in an ellipse, you know, the value that's bigger determines whether the ellipse goes this way or this way, okay? In a hyperbola, if you remember from Desmos, some of them went up like this and some of them went sideways. That has nothing to do with A and B at all, doesn't matter. Okay, what it has to do with is which one of the variables is positive, okay? So in this problem, see how this one is the positive one? So that means that the vertices of the hyperbola are going to be on the x-axis, okay? So this is the x-axis, so this is going to be the vertice right here, and the hyperbola is going to go like this, okay? But you're not allowed to just draw like any old hyperbola. What you have to do is the whole point of the box is you draw diagonals through the box like this. And then the asymptotes you draw, those are called asymptotes. The asymptotes that you draw determine the shape, and then you just draw your red one. So your hyperbola goes like this through the vertex and out, and then it just follows those asymptotes. The asymptotes kind of tell you how wide it opens, okay? So again, the reason why it went like this is because the x is first. It doesn't matter if this could be a super small number and it would still open up in the x direction, okay? All right, and then the other thing is a hyperbola does have foci, just like the ellipse, okay? But in an ellipse, the foci would be inside. In a hyperbola, the foci is outside. So it kind of resembles like two parabolas, okay? All right, so to find the foci, okay, do you remember how in an ellipse it was like a squared plus, a squared equals b squared plus c squared? In a hyperbola, it's a little bit different. This represents c, so it's a squared plus b squared equals c squared, just like the regular Pythagorean theorem, okay? However, the catch, the thing that, like, I don't want to always have to remember that. What I always remember instead is C is the distance to the foci, just like it is in the ellipse, and the foci are out here. Like this is a focus, this is a focus. So if you look at your picture, this, which is C, is clearly bigger than A, and this is also always bigger than B. So when I do my little equation like this, okay, instead of memorizing whether this is C or A or whatever, I just make sure that this has to be the biggest. And in a hyperbola, okay, it makes sense that the foci would be the biggest number because it's outside of the shape, okay? So one of the hard things about hyperbola is it's so similar to an ellipse that people get the two of them confused. So just make sure you're really careful, okay? And by the way, you have all your notes with you. So don't stress about like the formulas, just use your notes. If we ever do test on this, because of the weird situation, I will let you guys use notes for this, okay? So don't stress about that part, okay? All right, so the foci would be out here, and the distance from here to here would be C, okay? All right, so when we practice this, like if you're feeling a little confused right now, when we do an actual real problem, it'll probably feel easier, okay? All right, so we're gonna draw one more of these kind of abstract pictures. Unfortunately, I don't really think I have room on my paper to keep this up here, so I'm just gonna erase that, okay? So there's two equations of the ellipse. That was one of them. Okay, the other one is where y is first. So y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay. So in an ellipse, we kept the x first and the y second always and switched the a and the b. In hyperbola, the a's and b's don't switch because their size doesn't matter. Remember that, okay? This is smaller than c, this is smaller than c, this can be bigger than this can be bigger than that. Doesn't matter. All that matters is in the y direction, you're going to go out a. In the x direction, you're going to go out b, okay? And because this one's positive, the vertices are going to be on the y-axis. So this hyperbola is going to go like this, okay? All right, so we draw this picture. Okay. Let's just pull the center off so you can kind of see what that would look like. So draw yourself an axis. Okay, let's say the center is right here at HK. Okay. All right, so what this is saying is that in the y direction, you're going to go up and down A. Okay, so if this was an ellipse, you would just go up and down A. Okay, that would be A from here to here. In the x direction, okay, you're going to go out B. And we don't know which one's bigger, so I'm just going to guess. I'm just going to say B is out here. Okay, let's see. If I don't stand in front of it, it's hard. There we go. Okay, so this is B. Okay. All right, and then again, instead of drawing the ellipse, because if this is an ellipse, you would just simply draw it. Instead of drawing the ellipse, draw a box around it. Okay. So the underneath the x determines like how wide the ellipse is, and underneath the y turns out like how tall the ellipse would be, right? So now that determines our box, okay? All right, and then you draw lines through the center and the corners of the box, okay? And then you have to remember, this is the part people mess up on the most, is it doesn't matter that it's longer here. These are not where the hyperbolas go. Because the y is first, the y-axis determines the hyperbola, so it goes like this, okay? All right, and then the foci would be up here, focus, focus. Okay, all right, so if that wasn't enough, there's one more thing I have to introduce to you, and that's we are going to have to find the equation of those asymptotes, okay? They're just lines. You guys should have learned when you took algebra 2 forms of a line. Y equals mx plus b, which is called slope-intercept form, and then you should have learned something called point slope, okay? So we are going to use point slope. This is called point slope, okay? Point slope says y minus a y value equals slope times x minus an x value. So x1 and y1 would just be any point on the line, okay? And then of course m is the slope, okay? Well, here's the good news. When we do these asymptotes, the asymptotes are always going to go through the center, like every single time. So instead of using y1 and x1, we're going to use y minus the center equals, and then if you notice, there's a line that goes this way and a line that goes this way. The only difference between those two lines is this one has a positive slope and this one has a negative slope. So you're going to do plus or minus x minus h. Okay. So this will tell me the equation of those two lines. These are the slopes of the lines, and this is the point, the center that it goes through. Okay. I know this is a lot of information. Let's do 2 examples. I think that'll help clear everything up. And then if not, just email me. I could always do videos on how to do the homework too if you guys have enough questions on that, okay? All right, so we're gonna do 2 examples, okay? First one, Let me erase. Where's my eraser? There we go. Okay, so I'm going to write my equation over here this time so I can use my graph board. Okay, I want you guys to write down y minus 3 quantity squared over 9 minus x plus 2 squared over 5 equals 1. Okay, so let's just start with the basics, okay? You see this equation, first thing you should say is it's a hyperbola. And you know it's a hyperbola because y is being squared and x is being squared, so it's not a parabola. And this right here, this makes it a hyperbola. Okay? If that was a positive number, it would be an ellipse. Okay. So, because this is first, I know that my hyperbola is going to be in the y direction, so it's going to go like that. And sometimes I just draw that first so that after I do all my work, I don't accidentally draw the wrong picture. Okay. All right, so this is what you should do first after I secure my board. Hold on. Okay, so the first thing you should do is always find the center. Okay, so the center, you have to be careful because it's always x, y, even if it doesn't come in that order. So x, y. Okay, so on your graph paper, go ahead and draw me -2, 3. And that's going to be the center. Okay. All right, now we're just going to kind of pretend that we're drawing an ellipse, but don't actually draw one. Okay, so underneath the y is a 9, which means that we go 3 up and 3 down. Remember, these always correspond to the direction of the variable. So from here, I'm going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. Okay. In the x direction, there's a 5, which means I have to go √5, which is just a little bit bigger than 2 in the x direction. So I go like this. Okay. So looks like from your homework that you guys are pretty comfortable with the ellipse. So if this had been an ellipse, you would just, draw one. The only thing you're going to do different is instead of drawing an ellipse, you're going to draw a box. So you're going to go out like this. Okay. All right. The next thing you're going to do is you're going to draw asymptotes through the center and the corners of the box. So the corners of the box and the center are the asymptotes. So take your pencil and go straight through the corners, through the center, through the corner. Okay? Through the corner, through the center, through the corner. Okay. So this is the important part. Okay, your hyperbola, in theory, could either go like this or like this. And the way you tell is not by the size of the box. Okay, the way you tell is that because y is first, the hyperbola has to have vertices on the y, parallel to the y-axis, which means this is my hyperbola. Okay, again, the vertices are, this is a vertice, this is a vertice. The vertices are parallel to the y-axis like this. So they have, each has a vertice, a center, okay? There are no co-vertices because there's only 2 shapes, okay? And then the foci, we know are out here. Remember the distance to the foci is always the biggest. So this is actually really easy. You just take, these are B's and A's, right? You just take these 2 and add them up. So the distance to the foci squared equals A squared plus B squared. So just take these 2, add them up. You get C squared equals 14. C equals the square root of 14. That doesn't reduce. That's a little bit bigger than, it's like in between 3 and 4. So you go 1, 2, 3, and a little bit more. And you get a focus. Okay, and then you go 1, 2, 3, and a little bit more. And you get a focus. Okay, and since those foci are at strange spots, I am going to write those points down. Okay, so this focus right here is over 2, so -2. From the center, which is 3 high, you have to add √14 to that. This one is over 2. Okay, from the center, which is at 3, you have to subtract root 14. Okay, all right. So we're not quite done. Now you always have to write the equation of these asymptotes, okay? Remember, the asymptotes always go through the center, okay? So the general equation is y minus k equals plus or minus the slope x minus h. It's h and k because it has to go through the center. This is just simply going to be the slope, okay? So y minus 3, because remember this is h and this is k, equals plus or minus, and then I know you guys all know how to find slope. Okay, slope is rise over run. So start from the point that it goes through. If you rise, it's up 3 right here. Okay, all right, and then if you run right here, okay, you have to be careful. It's up 3 over root 5, so this is root 5. Okay, so the slope is up 3 over root 5, and I get those numbers from here, up 3 over root 5. Okay, so the slope is up 3 over root 5, and then x minus the x part is x plus 2. Okay, the only thing is I do want you to rationalize this, so your final answer would be y minus 3 equals plus or minus 3 root 5 over 5 x plus 2. Okay, so this is just the rationalized version of that. All right, so we're going to do one more example. You can either try it on your own and then fast forward to see if you got it right, or you can have me step through this with you one more time, okay? Okay, this one is x minus 1 squared over 4 minus y plus 2 squared over 12 equals 1. Okay, so this is my first question for you guys. Is the hyperbola going to go like this, or is it going to go like this? That's the first thing you should always ask yourself, okay? So if you look at the problem, don't look at these numbers. It doesn't matter which one's bigger. This is what you're looking at. This means that the vertices are parallel to the x-axis. So if you drew and you drew this, which one would be parallel to the x-axis? It would be this one, okay? So our hyperbola goes sideways like this, okay? All right, so first thing you do is you find the center, which is 1, negative 2. Now you're just pretending kind of like it's an ellipse. In the x direction, you go out 2 from the center. In the y direction, you go up and down root 12, which is like 3.5. 1, 2, 3. The root 12, 1, 2, 3, root 12. Okay. Instead of drawing an ellipse, draw me a box instead. So out, down, over, up. So a nice little box. The ellipse would be inside the box. The hyperbola is outside the box. Okay. To draw a really nice hyperbola, you're guys going to want to have to draw those asymptotes first. So through the corners, through the center, through the corner. Okay. Through the corner, through the center, through the corner. Okay. All right. And again, this is really important because the x was positive. These are the vertices. Okay. And your hyperbola opens this direction. And then the foci, of course, are right here, okay? So again, to find the foci, remember this is a squared and b squared. C squared equals a squared plus b squared. C squared equals 16, so C equals 4. Okay, which means that the foci are 4 away from the center. So 1, 2, 3, 4. Since that's a nice point, I don't have to actually find the coordinates. So then here, 1, 2, 3, 4. foci. Okay, so don't forget, you have to draw the box, draw the asymptotes, find the foci, okay, and you have to find the equation of the asymptotes, okay? So the equation of the asymptotes is y minus k equals plus or minus the slope x minus h, okay? This is h, this is k. So y plus 2 equals plus or minus, and then the slope is rise over run, okay? So if you're here, this rise right here, you have to look underneath the y value. That was the square root of 12, okay? And then the run was underneath the x value. That was 2. So this has a slope of root 12 over 2. But of course, root 12 is 2 root 3. So make sure you reduce that. So the slope is 2 root 3 over 2, okay? Which reduces, okay? Those 2's cancel, so you just get root 3, and then you get x minus 1. Okay, so let me just write that a little neater. Y plus 2 equals plus or minus root 3 x minus 1. Those are the equations of the lines, like the asymptote lines. Okay, so try this tonight. It's only Monday, so if you have questions, just please let me know. We're going to do hyperbolas for 2 more days, so this isn't like the only day you're going to get this, okay? So, all right, so I'm going to see you guys tomorrow. Bye.